Okay, so we bound this one and we bound this one. Now for completeness we will bound this other terms. Okay, so first let's bound d1 I have 1 plus b. Well, for this we can use that. Because of this we can say that d I1 I have u is less than equal within a constant than norm u hr1 I have. Okay, so this will be less than equal within a constant than u plus b norm h1 I have less than equal than u h1 I have plus b h1 I have. Okay, so we have done this, this. We can do a similar thing with this. That will be d1 I have u minus b 2. We will just need to have 1 minus b h1 I have. That will be okay. Now we will see what happens with this one. So this will be the term d1 I have u minus x, but now with a plus, and like we can use that the convolution is associative. We will just want to bound this e minus mu x convolution u squared. Okay, number 6. So this will be, we make exactly the same that we used before. We will have that this is less than equal within a constant to d minus 3 halves q squared normal 6, and now we can bound it again with the kernel g mu 3 halves convolution u squared, and once again we can use Young's inequality, weak Young's inequality, and we will have that this is g mu 3 halves in the norm to weak, and now we'll have the norm of u squared norm 3 halves. Okay, so we can have this to be less than equal, well, if we use Holder, we will have norm u squared 3, and we can bound this by norm u squared h1 half. Okay, this by Sobolev inequality, and this by Holder, because here we had u multiplied by u norm 3 halves, and it will be less equal than u norm 3 u norm 3. Okay, here was the absolute value. Okay, so we obtain this bound. So for both we will have u squared h1 half plus b squared h1 half. Okay, so we have this one, we have this one, this one, this one, let's see this one. Well, in this term we will have e minus mu x over x, and we separate again u squared infinity, and this we've done it before. Is exactly the same thing we did for the first part, for 1. Okay, so we know that this is bounded by 1, let's put it here, minus 1/4 u squared, and so the global, all this was bounded by, well, when we had this with u, this with b, and this was smaller than u squared h1 plus b squared h1. Okay, so this was the bound for that. Now that we bounded all, let's put all together. So first, this bound multiplied by this. So what was the bound for this? So here's the bound for this. It was u, well, we had this, and if we use this estimate, we will have the u h1 plus b1 multiplied by u minus b3, but this is less than equal than u minus b, h1. So let's put this. So the first bound is this. What will be the second one? Well, let's see. Well, multiply by u plus b in norm 3. That can be bounded by u h1 plus b1. So it will be 2 times this, or this, we can say this squared. We can just leave it like that, okay? So now the following term, well, this. So here it is, and the bound is u h1 plus b1, u must be h1. So once again, h1 plus b1, u minus b. But it was multiplied by d1 u plus b. And we had the bound is u h1 plus b h1. Okay? So u plus b h1, we will have squared again here. Plus, what's the next one? So d1, okay, this term, here's that term, and we bound it by u squared h1 plus b squared h1, which is u squared h1 plus b squared h1. Okay, but if our u minus b 3, but we can bound that with the same 1/2, so we will have u minus b h1. Here I forgot the h1. Okay, so what's the next one? This. So how do we bound this one? Well, u squared h1 plus b h squared h1 is this. U squared h1 plus b squared h1, and what else do we have? d1 u minus b. This will be bounded by u minus b h1, u minus b h1. Okay, so this is the total bound for 2. So as we have this bound that when we have u h1 b h1 squared less than or equal to u squared h1 b h squared h1, as we have that, then we can bound both of these by these ones. So we have really here the same term. So at the end we just have the 2 is less than equal than u squared h1 and a half plus b squared h1 and a half u minus b h1 and a half. Okay, and that's what we wanted to bound for the second one. As you may remember, we had the same for the first one, the same bound, so we finally have what we wanted to prove. We have that ju minus jb h1 half is less than or equal than this u minus b h1 half for all u b in h1 half or 3. Okay, so we finally conclude that ju minus jb h1 half is less than or equal than 1 plus 2. This is less than or equal than u squared h1 half plus b squared h1 half and u minus b. Okay, h1 half. So that lemma together then A is self-adjoint. Okay, A is self-adjoint. Here goes the square. Okay, this is with it's a self-adjoint operator in L2 with domain in H1. Okay, and its extension to H1 and a half. Well, we can say A takes a function in H1 and a half, turn it to 1 in H minus 1 and a half. This generates a unitary group of operators inside TA. So as we have seen, this gives us an existence of uniqueness locally in yt. Okay, for the integral equation, yt is c0 0t h1 half r3 with the norm dispriminum of the t's in the norm h1 half. So local world Boson follows from the general theory on semilinear inclusion equations, and this will be proved in one of our videos before we start with Boson stars.